June 5th. I have some work to do after this, so I hope it's not too difficult. Using a robot to print the lexicographically smallest string. You're given a string and a robot that currently holds an empty string. Apply one of the following operations until S and T are both empty. Remove the first character of a string S and then give it to the robot. The robot would append its character to the string T. Remove the last character of string T and give it to robot. The robot will write this character on the paper. Return the lexical smallest string that can be written on the paper. You can apply one of the following operations until both S and T are empty. Okay, so S is Z, Z, A. T initially is empty. So what we can do is remove the first character of S and then give it to T. Give it to the robot, and the robot will put it in T. Or we remove the last character of a string T and then give it to the robot, and the robot will write this character on the paper. Return the lexicographically smallest string that can be written on the paper until them both are empty. So essentially we are moving from the start, right? From the start, and then this one is, so basically you just put ZZA. So you're just reading it this way, right? Reading it this way, and you put in there. And when you move the last character. So as you go, the moment you find the smallest, this one can go into the thing. And then you do Z and do Z. So it's like a stack, right? You put Z, and you put A, and it can be a lot more, but definitely you want to pop. But the thing is, as you put more things in, and when you pop, it has to pop according to this order, right? So I think we probably have to go through Z first to understand what is in it. And it has to be the lexicographically the smallest string. So we can read through this, right? I'll find the small one. You know what? Let's try another example. So BAC, okay, B, and now we have A. So A is small. So does that mean like when we have a small, we can always just pop the small? Does it matter that we pop early or we pop late? So in this case, we do pop, and then last one C need to come in, and then we pop. So we go to ABC. Let me think. So essentially we read this. Okay, I'm gonna do it one more time. B, D, D, A. So when we put it in it, it's just reading this way, right? Reading this way. The thing is, if I don't like, we have, let's say, BA something something, right? If I pop A, but I don't pop B, and I wait for them to come in, then B is locked. I can no longer pop it until I pop these, right? So the question, if I have like more A's towards the end, let's see this one. So we'll go B. I don't have an A, right? So we want to pop A, but if we pop A first, we have to pop D, and B. Like we do this, that's the only way to handle it. Huh. But it is always better to get the smallest out first, right? The first one has to be the smallest, because if the first one is not the smallest, then there's no point. Okay, so we can find the smallest, and that one has to pop. And once we have the first smallest, and then we need to know if we need to like the smallest we get popped, then what? Right? So we pop the smallest, then we have a bunch of the other things going. Ideally, if I multiple smallest, is definitely I should get all of them, right? We definitely should get it. Like every time we hit it, we should pop it, because if we don't pop and some other comes in, then there's no way that you can pop. Right? There's no way you can pop, because you can only remove the last character of string T. So that means if we have multiple A's scattered, we should get all of them, right? And once we get all of them, then part of the string is already settled, right? If we say, like, if we have something 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 and A, something 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 A, something 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 A, something something, right? So if it's a string looking like this, and we say every time we hit an A, we need to pop it, because if we don't pop this, and we got these piled on, and you say, okay, now I want to pop this A, then you can never get to this A, because you have to get to these things first. So now you say, okay, I'll pop this, and like beforehand, I know there are multiple A's. So I say, I'll pop this, but then I'll pile these on. I pop this, I'll pile these on, and I pop this. So these are free so far, but this is set in stone. There's no way for you to change it. There's only one way to pop them, right? So once you get A out, there's only one way to pop them. Let's say these are free because there's no more A's in them, right? There's no more A's in them. So the next should be comparing this guy, right? So this with everybody in here. If this one is bigger than the remaining, then if we pop here, it's gonna make it big, right? So we should wait to pop the small. So we need to know the smallest in the remaining, right? We need to know the smallest in the remaining, and we need to pop that. Well, we'll compare the smallest in the remaining with the setting stone one. No, not this one. We're setting stone one. So it's the same with everybody else. So basically, we put everybody into a main heap, right? We put everybody into a main heap, and with this indices. Okay, so it's like in the index. And then we have the first one coming out, and then the remaining will give me the min, right? The min. And the min will be determined by both the letter and the index. If the letter is the same, the smallest index goes front. Okay, so that will give us the minimum. And it say this index, this one's the minimum, right? So, and this one is smaller than this, so I just keep going, right? Keep going, and every time we go, and when we pop, if it has been handled, we just don't add it. And then we hit this, we put this into the result. Okay, we put this in the result, and this is the front. And again, we compare. Okay, so now I need to know how to create a priority queue with custom compare, because I forgot how to do the custom compare. This is where large language model shines. So LeetCode 2434. Okay. The ideal is that we put all the letters in S in a main heap that first compares the letter size, and if the letter are the same, compare the indices. We put the index, we put the smallest index with the smallest letter at the top, right? Then we compare that smallest letter with the top of the stack, with the top of string t, right? That's essentially with the top of string t. If the top of the main heap is smaller, we keep pushing new letters into t until the min is achieved, until min is encountered in the main heap. Otherwise, we pop t, right? We pop t. So I think this one shall work, but I need to know C++ main heap custom comparator. I forgot how to. So priority queue main heap comparator. Okay, that's exactly what I need. Copy and paste. Let's do this. All right, I think I need to get this one first. All right, main heap comparator. I just call it comp. Okay, this is a comp main heap. It's fine. This should be comp. Okay. So we have AB. We then return. It should be S. So if SA is equal to SB, okay, then we return A larger than B, okay, smaller. Otherwise, return SA larger than SB. Oh shoot, we need this. So this is same letter. Choose smaller index. Different letter, choose smaller letter. Okay, so that's our priority queue. We have a main heap. Then we're gonna put everybody from S into it except for the first one, and also need a I think a vector is enough. We say int stack. Okay, and we say stack dot pushback 0. We also need a string result. Okay, and then for int I equal to 0, I equal to 1, smaller than s dot size I plus plus. We're gonna do main heap dot push I. the deal. So we'll do that until the heap is empty, because we keep going, right? We keep going, so the heap will get empty. The heap will go empty. Well, let me think. So we'll wait, and then we'll go blah blah blah, and then we'll push this one out. I'll push this one out, so the top is the maximum that we have, and then we keep going, and eventually, if there's no heap, then okay, we're gonna say while stack.empty, right? If stack is not empty, or main heap, because it could be stack is empty but main heap is not empty, right? And then if stack is empty, the main heap not empty, I just pop this one into the stack, right? If stack is empty and a heap is not empty, then I just keep popping this out into stack. No, you don't even need to put into stack. You just, yeah, I know. So main heap dot empty. So we should say if this is not or not, right? If these are not empty, then what do we do? So if stack dot is empty, right? If stack is empty, oh, actually no, we can do this. And, right? So neither of them are empty, right? Neither of them are empty. And then what we're gonna do is to compare the top of stack and top of heap. Which one's smaller, we'll pop that one, right? Let me say if s stack dot top. I don't think it's a top. I think let's just do stack. I think stack has a little bit more. It's easier, right? It's stack. Okay, I can do top, right? If s this is smaller than what I call smaller equal to main heap dot top, right? If that's true, then we will do that, right? Then we just say rest dot pushback s stack dot top, right? And then s dot pop back. Okay, so we go back. Else, then the heap is smaller, right? Heap is smaller, so rest dot pushback s main heap dot top. Okay, and then as a main heap. Oh, it's not s. This is a stack. S. There we go. And then what is the main heap dot pop? Right. There's also one more thing, that is if stack dot pop. I guess just pop then. Push and pop, right? One more thing, if main heap because we keep adding stuff, right? We keep adding stuff, so the top of the heap has to be bigger, right? If the top of the heap is smaller, and then it's already locked in. So we just say if min heap dot top is smaller than stack dot top, then we do min heap dot pop and continue. And then we do all that. So then it will come out. Now we say if stack dot empty, right? If come out stack is not empty, but the other one is empty, then we'll do rest dot pushback stack dot s stack dot top, right? Stack dot pop. If not min heap dot empty rest dot pushback s min heap dot top and min heap dot pop, and eventually we'll return rest. Alright, something of this sort. Let's see if it works. Looks reasonable to me, but the last one we got wrong. We even got a total wrong. So B, oh, I didn't add. Oh, you never add. My bad. There is some issue that I forgot. So if this is smaller or equal to this, then we'll pop this, right? But if otherwise, then it depends. Then it depends. Right, here is something wrong. So here is else, then we need to check if, because stack what is the current index that we have gone through, right? So the next available. Let me think one more time. We're almost there. So much later, so I have to keep going, and then they have to match, right? And then I do that, and then I have the next one, and I will pop, and then I need to keep going. So yeah, so the only time that we can do the pop is if else if stack dot top a plus 1 equal to min heap dot top. So it means min heap is ready to pop. Okay, then we do this, then we do this, right? And then have another else. If stack dot pop plus 1 is not equal to, then we should say stack dot push stack dot top plus 1. Okay, so changing the logic. Let's give this a shot. Oh. Added one more than I need. Interesting. else if, again, damn, stack dot top plus 1 is smaller than s dot size, then we do it. Otherwise, we don't do it. What? Okay, so we have z in it. Okay. And then we have a as the largest. So stack top smaller than no. Stack top plus 1, no. And then we say, okay, then we say stack top plus 1, yes. So stack push, so we push the second z in it. And then next one, plus 1 is equal to min dot top, yes. Then I'll rest I'll push by min. Okay, so a is gone, right? A is gone. I think it shall be smaller or equal to, because it's already on the stack, so it shouldn't be considered again. Ooh, this is interesting. Ah, Lord. So I have ZZ, right, in the thing, and the next one is main heap dot top smaller or equal to. It should be a true, right? And it should be main heap dot pop, right? And then it's not. Well, I mean, it still is main heap dot top smaller, so main heap dot pop. And main heap is empty, and then stack should have 2. Should pop z and then pop z. I think in this scenario, the best that we should do is not to think, but use the tool. And the tool is called debugger. Let's go debugger. Okay, let's go debugger. 06, 6, 6. Okay, looking good. Let's start from here and then F5. All right, let's see. Add the debugger up. We don't need you. We don't need you. This is what I want to call. Is it F2? Yeah. All right. So main heap. We have 2 and 1. 0, 1, 2, 2 and 1. Yeah. Stack. We have 0. Good. So main heap top is 0. No, main heap top is 2. Is smaller than no. And then stack top, that's a Z. That's an A. No. No. So the else if 0 plus 1. No. So we do this. So stack, we push 1. Perfect. Next, that's still the top is 1. The top is 2. Stack top is 1. And no. And it's still no. But now the stack plus 1 is equal to this. Okay, so rest I'll push back. So rest got A, and main heap we got it popped. Good. Next, main heap top is 1. Stack top is 1. Okay, so they're equal. So I say main heap pop. Alright. Continue. Get out. Stack is not empty. Yes. Then the pushback. Stack dot top is 1. So I put a Z. Stack dot pop. Oh shoot. Oh. I was like, doesn't make any sense. I forgot. Okay. I forgot. I forgot. This should be a while. It's not a if. Jeez. And this logic, if they're the same, then I pop the main heap. Well, yeah. I mean, if they're the same, that means it's already part of the thing. Oh, actually, I don't know. If they're the same, who should be gone? Oh yeah, main heap gone because the next one will be bigger. Right, then we'll do this. Yeah, it's fine. Alright, let's just do one more test case. Let's say and see if this one will work. Okay, one more edge case. Maybe a few more. Let's say we have a bunch of A's. Let's say we have a single letter, right? Let's say we have just lots of this. Okay, so if this one passes, we are going to submit it. Ooh, good call. What happened? What happened? Oh, this is absolutely interesting. Let's get rid of. Let's see. Let's get rid of everybody. Slim this down. Maybe we do this. Yep, we have this effect already. So we have A at top, so we get A, and then we have Z, and we have another A, so we get A, but we go to Z. So we get all the A's out. I don't understand. I don't understand, but we can always try. Alright, let's try. Let's try. Oopsie doozy. Alright. Same old, same old. Okay, so we have the heap. And this is a 0. Okay, so now we're gonna go. Top is smaller, no. Stack, no. And this is yes. So I pushed it in as A, and now I pop it. Cool, now 3, 0, 1, 2, 3. Okay. So next, it's a 3, so it's a no. And it's a no, that's a no. So I'll be pushing stack dot top. Oh, shoot. I see. Oh, damn. 1 is already in, so I cannot do top plus 1. Oh, Jesus. So what is the next one? Huh. Yeah, you whatever that is pushed in, right, is the current front, the largest index. Hold on. So if I do this, okay, and then I wait, and I do this, and then when I wait, so every time when I wait, it should be. So like, why would you push more into the stack? You only push more into the stack if the one you're waiting for, right, is not ready. So you need to know what is the next one to push. So the next one to push could be stack top plus 1, or it could be whatever is in the current anyway. I think I know. So this is definitely a possible candidate for the next one, right? Because I have A is right there, and then we have something small right there, so we need to reach there, right? We need to reach there. But the next one to go is going to be, because I just pushed one out, right? I used this, so I actually increment, right? So the next one coming in cannot, to push into the stack, I cannot be smaller than this, right? To push in the stack has to be something that has not been handled. So basically the largest between whatever is in the string and whatever is at the top of the stack. So let's just use a one more int res top index res in res. Okay, we start with -1. All right, so every time res dot pushback, then because we need to maintain the top. That can be something, right? And then I will wait, and then I do something. And then when I do this, so the top is actually getting smaller, right? So what we want to is to find the largest. Yes, we do want to find the largest. So when do you hit the largest? Well, every time you push back, so you will say top index in res, so equal to maximum top index in res and stack dot top. We keep track the largest every time you do. Maybe it's not necessary to do this every single time, but let's just be safe, right? Okay, so here is the thing. If this plus 1 maximum, right? So it should be the maximum of this and top index. If this is smaller than 1, then we can push. Actually, we don't need to, right? We don't have to. We just make sure we don't. I guess it's fine. So we'll do maximum stack.top plus 1 top index. Shouldn't this plus 1 as well? Right, this should plus 1 as well. So I can do this plus 1 plus 1. Let's try this one. Nope. Oh yes, I was going to say nope. Okay, now I'm bringing back everything and see if it works. Alright, I think now I have sufficient confidence and then we can try it. And we still got it wrong. Jeez. It's 41 minutes in and then we still got it wrong. Fuck me. BD, I did do F first. I think that was the order. I got the order wrong. So I have V, right? And then B, Y, D, I, Z, if, V, E. So I have B, and then everybody, nothing is smaller than B. So I do B, right? And then, oh, wait, hold a second. Yeah, this is not right. This is not right. I cannot. Oh crap. So yeah, B is in, but now stack is empty. So next we need to know, I want D to come out, right? But then I need to put Y in it. Then. So stack empty shall be expected. Stack empty should be expected. And if stack is empty, I basically do the top index in result plus 1. We put that in. If stack is empty. So we do that. Hold on. So what you're saying is we can even not do this, and then we can put everybody into the main heap, and we don't do this. And we say if stack dot empty, right? If stat is empty, then we do stack 1. And we'll continue. And we still have the problem when this is empty. Well, this won't happen, right? This won't happen because I will, when it's done, it will definitely be only stack can have the possibility. There we go. All right, try this one. Oh, that was brutal, the performance. But yeah, we got this. Terrible. 9.9%. This is as bad as it can get, man. Well, not necessarily. The worst is you don't pass. Alright, let's see. A tutorial. It must be some... Oh, greedy! Goodness me. We have character and we have a counter. We have a stack. Main character. We go through everything. Stack dot in place. I'll just push it back. Counter minus minus. So we push it in. We minus the counter. If the main character is not equal to z, and this counter is 0, we don't have main character anymore. So main character plus plus. So we move on to the next main character. And this is a while loop. So basically we hit the first one, okay, and we decrement on the counter. Then we check if the main character is still the same, right? If it's still the same. If it's not the same, let's say the first character is the main character, and there is only one main character. And then we have to move main character forward. And we say if the main character is not, if that stack is not empty, and the top is smaller than the main character, it's the main character of the remaining, right? And then we will use the stack. I don't know. I need to think about this more. I'll think about this more. I mean, this definitely works, but I think there's a slight difference between this and this, right? This basically, you're keeping track of the main character. That's what you're doing. You're keeping track of the main character, and you put every single letter into the stack. You put every single letter into the stack, and then you just decide when we need to pop it out, right? So the when happens when the top of the stack is smaller than the remaining minimum. Right? If the top of the stack is smaller than the remaining minimum, then you should pop the top of the stack. And remaining the minimum is, we're using this to decide what is the remaining minimum. Right? So remaining, we have a minimum value, and we say if there's some minimum in the remaining, we should wait for it. Or we should wait for it. And the moment that minimum gets released, we shall use it. right? We'll use it, and that's it. We use it, and then we keep going on. Okay, I actually think this is a good one that I want to try it again. Yeah, I think I'll try it again. Anyway, that'll be it for today.